Okay. Exam 2 should be on Canvas. It is due Monday at 11:59 p.m. And I did a grade update. If there are any assignments, including past exams or quizzes, write to me, and you can use XYZ or the school email, and I can give you an extension. After I grade the test, I'll do another grade update. We'll catch up on the grade book. Okay.
Soccer.
Yes.
I was gonna ask you, so for last week's homework, we had to use the infinity sign, and a lot of my problems were like only half a point because of the infinity sign though, because I think it was right, but just the infinity sign made the equation wrong.
Okay. If you could write to me on that one too, I think I can check your past attempts and I can score your homework for you.
Okay, thank you.
Yeah. So let me write that on the board. If you have any missing assignments or issues with assignments, please let me know so we can start to fix it. There are ways for me to check like the work you've done, the time you spent on the assignment, and I can override the scores or go problem by problem and score your homework. Oh no, if you've already written to me about it, I should be able to fix it. And yeah, I think I checked on that homework assignment. I'll check it again, but most likely I'll just have to give you credit, like manually score the homework. Okay, we'll fix that. So today is review for exam 2. Also, your exam covers homework 5 through homework 8. So those are the main topics. Most of what I'm going to do today is practice problems, but for the start of the notes, I want to do all of the rules for exponents. And then we'll use those rules and then we'll move on to other practice problems. Okay, it's base A exponent x. Multiply with a to power y. You keep the same base a, and the power is x plus y. if you have a times b to the x, it's a to the x times b to the x. Next one, a with power x divided by a to the power y is base a, power x minus y. For this rule, we just have a little side note that a cannot equal 0 because we don't want to divide by 0. A to the x to the y. So a has a power of x, and this all has a power of y. Power to a power, multiply them together. A to a power of x times y. Okay. This one has a to a negative x is 1 over a to the x. And the last one. We have a divided by b with power x is a to the x over b to the x. And this one also has a special note. We don't want to divide by 0, so we're just going to note that b does not equal 0. Okay, so we're simplifying this problem and going to write our answer with positive exponents. In parentheses, it's x to the 8th over x squared. then all of this has a power of 5. So there are different ways to solve the problem, like most math problems, but as long as we follow the correct rules, we'll reach the same answer. So what I did was I stayed inside the parentheses where there's x to the 8th over x squared and use the base x with a power of 8 minus 2. And I still keep that other 5 on the as an exponent. Okay, x to the 6th to the 5th. Would be x to the 6th to the power of 6 times 5. So I've got x to the power of 30. And that's my answer, since I do have a positive exponent and I've gotten this down to just one value of the variable. Another exponent problem. So it's just an expression that we want to simplify. And I'm going to ask that you write your answer with positive exponents. There is 6a squared b, and it's all squared. Divide by 18a cubed. And we're also going to put b with a power of 0. Okay, so before we go through this problem, after all of the rules we went through, I forgot there's 2 definitions. There's the definition with power 1 and the one for power 0. So we're going to put those on the board, like aside. Okay, for any number a to the 1 is a. For any number b, actually, for all non-zero numbers b to the 0 is 1. So again, this is true as long as b is not 0. Okay, so back to doing our problem. I'm first going to start working on this numerator. I can put the power of 2 on 6, on a squared, and on b. And then I'm also going to work with this part right here, b to the 0. It's going to be 1. Okay. 6 squared. A squared, and B squared over 18. And we said b to the power 0 is 1. So just replace that value. 6 squared is 36. A to the power of 2 times 2, which is a to the 4th. B squared. Divide by 18. A cubed. And when you multiply by number by 1, it's still the same number. So 36 over 18 is going to be 2. A, the base is A, and the power is 4 minus 3. And then you have the B squared just sitting there. So it's 2A to the first, B squared. And we mentioned earlier that anything with the power 1 is just that same number, A. 2AB squared. All right, we're going to do I have some other exponent problems, but I want to make sure we touch on all of the exam topics. So we're going to do something a little different, but we might come back to using these properties later if there's time today. Okay, next one is going to say subtract and simplify. With 5x squared minus 3x plus 2. And then subtract 3x squared plus 4x minus 7. And if on my paper, I have it all written, just straight across, but we're going to do this polynomial, subtract that polynomial, and then once we distribute that negative sign, we can combine like terms, and that will be how we simplify this expression. So let's do this. Okay. So we take this, I'm just going to copy it again. There's 5x squared minus 3x plus 2. We're subtracting the 3x squared plus 4x minus 7. I need to distribute this negative sign to all 3 terms. So from that first polynomial, we can drop the parentheses. It won't affect any of the terms. It's just a 5x squared. Subtract 3x and add 2. And we talked about distributing the negative to get negative 3x squared. And minus 4x. And plus 7. Right. Then you want to combine like terms, like the 5x squared and the negative 3x squared. There's a negative 3x and a negative 4x. And then 2 and 7. So looking at your x squared values, there would be 2x squared. And then a negative 3x with negative 4x is negative 7x. And then positive 2 and positive 7 would be a positive 9. Cool. I think that's it. So next we multiply and simplify. We're going to take 3x minus 3, multiply it with 4x minus 2. Okay, so this is where we do the FOIL. Or you just want to make sure every term is multiplied with all of the other terms. So FOIL is a way to keep that organized. Cool. So it's first outside, inside, last. The first terms are here. 3x with 4x is 12x squared. Outside would be 3x times negative 2, which is negative 6x. Inside is a negative 12x. And the last part would be negative 3 multiplied with negative 2, positive 6. You want to combine like terms. So you've got a negative 6x with that negative 12x, it's negative 18x. So that's the multiply, and then we simplify. And then we're done. This time we want to find the quotient and simplify, which means like divide and simplify. 9x squared minus 3xy plus 30 xy, let's do cubed. All right, divide by 3xy. So what I want to do is just put the terms in the numerator over that denominator and then simplify each piece. So to start, we're just going to restate the problem. So let's try to see. Okay, start with that 9x squared, put it over 3xy. And then minus the 3xy over 3xy. And then there's a plus 30xy cubed over the denominator. Okay. Let's keep working. Okay, so we're looking at the first term. Where 9 over 3 is 3. X squared over x is going to be x to the first, and it's in the numerator. And that y stays where it is in the denominator. Okay, then there's a minus a number over itself, which is 1. Okay, plus 30 over 3 would be 10. There's an x over x, which reduces to 1, and then the y cubed over y is y to the power of 3 minus 1. So y squared. And then just a quick check, are there any like terms? No, they're all going to stay kind of separate, and that would be my answer. Okay, so this, again, I'm doing kind of a little of each problem. If we have time, we can go back and do more examples. But I want to go on to factoring. So we're going to factor out a greatest common factor. Okay, from 25x cubed. plus 15x squared. Minus 30x. Okay, just to get started, I want to find the greatest common factor. So it has to be common to all three terms and able to divide each of the terms. So for the numbers, you just want to kind of factor each one. 25 is 5 times 5. 15 is 3 times 5. 30 is 3 times 10. 10 is 2 times 5. Okay, there's a 5 common to all of the terms. So that's going to be part of the greatest common factor. There's a 5. That's it though. There's a 3 as a factor, but it's not common to the first term or the last one. Or never mind. There's a 3 here. But it's not common to the first term. And then there's a 2 as a factor, but it's only in the last term, not the others. Okay, move on to your variable. For the variable, use the smallest power, which is x to the first. X. So what I want to do is from this expression, factor out 5x. We were at the 25x cubed plus a 15x squared subtract 30. Factoring out 5x would leave a 5x squared. And then from here, factor out the 5, it would leave 3. Factoring out an x leaves 1x behind. 5, factor out of that last term, leave a negative 6. Then you've got the x out, so that's all that there is. Okay, and then that's the answer. That's the greatest common factor, and we factored it out. And we're done. Okay, so we're going to do 2 of the kind where it says factor a trinomial. One way we'll use a diamond, and one way we'll use a grid. It's x squared minus 7x plus 6. So the first way we're going to do this is with the diamond. And when I do both of these problems, I'm not going to skip to the answer. I am going to go through all the scratch work. So scratch. Diamond, we go like this. You take the first number, which in this case is 1, multiply with the last number of 6, and that goes in the top. 1 times 6 is 6. The middle number always goes on the bottom. That negative 7 is down here. And you fill in the signs by guessing two numbers that multiply to 6 and add to negative 7. So I'm thinking 6 and 1, but they're both negative. That way they multiply to positive 6 and add to that negative 7. So when I found the correct guess, I'm going to use the sides to rewrite the middle term right here. Ooh, okay. Our problem was x squared minus 7x plus 6. I'm going to use these numbers to rewrite negative 7x minus 6x minus x plus 6. So a negative 6x and a negative 1x, and then just, that last piece right there. And now we can group the first two terms, and we can group the last two terms. From the first pair, factor out x. We leave an x minus 6. From the other pair, let's factor out a negative. And that would make that value in the parentheses x and then negative 6. Just check that. If I went backwards, that would give me that negative x. And then if I go over here, that's my plus 6 at the end. So this is correct. And now between that term and that term, we can take out the common factor of x minus 6. So if I bring out x minus 6, from here it leaves that x. From here it leaves a negative 1. That would be my answer. Okay, this time we've got okay. With this 12x squared, add 20x, and add 3. This time I'm going to use the grid to guess and check, and also we're going to go through all the scratch work together as well. Okay, so we copy this down. And I set up my grid with the plus on 20x, and that plus goes on 3. On this side, you get two numbers that multiply to 12x, like maybe 3x times 4x or 6x times 2x, which I've already tried this a few times, and I'm going to go with 6x and 2x. But you might need to guess and check and use some scratch paper. Okay, on this side, you need two numbers that multiply to 3. So I'm going to pick 3 and 1, and let's just give that a try first and see if it works. If not, I'm going to maybe try doing 1, then 3. Let's see. You multiply across to get 2x times 3, which is 6x. Multiply across 6x times 1 is 6x. You add the sides together, and that would be 12x. But you want this to add up to the middle term of 20x, which it's not, so we're going to have to try again. Okay, let's try on this side. I'm going to set up a grid. I'm going to pick 6x and 2x again. But I'm going to put 1 up here and a 3 down. Okay, you multiply across. So let's go down this way and get 6x times 3, which is 18x. And this way would be 2x times 1, which is 2x. Okay, cool. When I add up the sides, I get 20x, which is my middle term. So I know from experience that my answer will be 6x plus 1 times 2x plus 3, but I'll show you the work in between. So this time you use these sides over here, and those sides rewrite that middle term. So let's work through the whole process together. So I've got my guess, and I take the 12x squared plus 20x plus 3 and rewrite the middle term. 20x is 2x plus 18x, both sides. That last value at the end. Okay, then we're going to group, and from the first pair, factor out 2x. Leave us 6x plus 1. From the second pair, factor out 3. Which will leave us 6x plus 1. Okay. From that term, added to that term, they have a common factor of 6x plus 1. So factor that out. From the first value, if you take away the 6x plus 1, it leaves the 2x. From here, factoring out that 6x plus 1 leaves that positive 3. And then we're done. And again, I kind of already knew that I'd get 6x plus 1, that first row, multiplied with 2x plus 3, the bottom row. Okay, for the next problem, we're going to use factoring to solve an equation. 6x squared equal to negative 5x plus 4. Okay, first thing we need to do is get 0 on one side of the equation because we need to use the zero product property. Part of that property is having everything equal to 0. So we have the 6x squared is equal to a negative 5x plus 4. So I can either subtract 6x squared from both sides, or I can add 5x and subtract 4. I'd rather do that. I kind of like when this coefficient on x squared is positive, just to have it. So again, I need 0 on one side of my equation. So I still need to subtract 4 from both sides as well. Okay, now I've got 0 over here, which is the first step, really. And over here is 6x squared plus 5x minus 4. It's going to get a little messy. So we're going to restate this problem. Copy down where we've gotten to so far. 6x squared plus 5x plus 4. We've gotten it equal to 0, which is like a really big first step. This side needs to be factored. So we want to take this, factor it. So if I were you, I would probably get some scratch paper. I'm kind of stuck on the board and just gonna do a little moment of scratch work, extra scratch work. I need to figure out how to factor this. I can use a diamond. I could use a grid. I'm a fan of this grid where you take your 6x squared, put the 5x and a negative 4 and draw. Where the plus is with 5x and the negative is with 4. And then over here you get two numbers that multiply to 6x squared. I think I want to use 2x and 3x. We'll see how it goes. Okay, on this side, two numbers that multiply to negative 4. Thinking negative 2 and 2. And it'll go across and across and see how that goes. Okay, this would be 6x. This way you'd get a negative 4x. If you add those together, there'd be 2x. And I want my middle term of 5x, so it's not going to be the right guess. Give it another shot. Trying to just factor this side somehow. Okay. 6x squared plus 5x minus 4. We're going to stick with 2x and 3x as two numbers that multiply to 6x squared. And then on this side, two numbers that multiply to negative 4 will go with 1 and 4, where we have a -1, go with +4. That would be -3x. This multiplies to 8x. Then you add up the sides, that would be 5x, which is my middle term. We could go through the work, which we probably should do technically, where we use these sides, this part right here, to rewrite the middle term, and then factor. It will factor though. I'm going to skip to it though. So we have got the 6x squared plus 5x minus 4. You should do the scratch work to be completely confident that we've done this correctly, but I've done it so many times that I know you're going to get 2x minus 1. And it's going to be multiplied with 3x plus 4. All right. And again, all of this was extra scratch work on the side to find out how to factor this part. So this factors into that, which means I want to take this piece in my problem and replace it with the factored form. Okay, so back to the problem. If this side is equal to 0, it means that 2x minus 1 times 3x plus 4 is equal to 0. Actually, I'm going to go over here. So it's like we did this over on the side, and we come back to where we were trying to figure out how to solve for x. This side can factor into 2x minus 1. 3x plus 4. Copy that part down. Multiply one number with another number and get 0. One of them has to be 0, either that one or that one. So it's that 0 product property. Number times a number equal to 0 means 2x minus 1 is 0, or 3x plus 4 is 0. Okay, and you want to solve these separately. So you're going to get one answer on this side and another answer on that side. Let's go here. Add 1 to each side. 2x equal to 1. Divide both sides by 2. And x will be equal to 1/2. Over here, you need to subtract 4 from each side. And 3x is equal to -4. Divide both sides by 3, and you'll have x equal to -4/3. Okay, and we also need to do at least one problem with inequalities and one problem with absolute values. So let's try solving this inequality. And we're going to put our solutions in interval notation. All right, it has we're going to go with -5 less than or equal to 2x minus 1 less than 5. Let's make it 7. Okay. So I want to make sure I keep all of my symbols the same. There's a -5 less than or equal to 2x minus 1, and then strictly less than 7. All right, so we want to isolate x by adding 1 to all parts of the problem. So add 1 here and on the side over here and at the beginning over there. Okay, this would be -4. Copy that straight down, less than or equal to 2x. And then strictly less than 8. And then divide by 2. Since it's +2, I don't have to flip the sign. That's only when you divide by a negative number. So if it's a positive, keep the signs the same, but you do have to divide on all 3 parts. So it'd be -2 less than or equal to x, and then strictly less than 4. Okay, for me, it would help to just draw a quick graph. So I would have my number line. I would mark -2, +4. I don't include 4, so it's open. I do include -2, it's closed. And I could test some points if I want to, but I know that I need the values greater than -2 this way, and also strictly less than 4 that way. So it's going to be this shaded part in between where both of those things happen. So we go from -2 over to 4, and I do include this side, but not that side. So the set looks like this. Is starting at -2 and includes that side. Goes over to 4. It's really, really close to 4, but never actually reaches 4. 4 is not included in the set. So we're going to do another one for the review, and it's about absolute values. And then if there's any extra time, we'll see if you have any other questions or things I should go over. solve. We're going to do this one. We have 4 equal to -1 plus the absolute value of 6 minus 1/5 x. Actually, we're going to minus x over 5, which is the same thing. With absolute value problems, you need the bars isolated. So you need your absolute value on one side of your equal sign or inequality sign, either one. Everything else on the other side. So I need this part by itself, which means I want to add 1 on both sides of your equation. Okay, this would be a 3, and it's equal to absolute value bar of 6 minus x over 5, another bar. Right. Now that I've got the absolute value of this piece equal to 3, either the value inside the bars is equal to +3, or the stuff inside the bars is equal to -3. So you set up 2 equations. You take what's inside the absolute value, 6 minus x over 5, put it equal to this distance, which should always be positive. So this is what should I say? Before you remove the bars, this number should be a positive number. When you remove the bars, you take that number and you put a positive of it and you put a negative of it. Okay, and then solve each one. So I would subtract 6 from both sides. This looks messy. So negative x over 5 equal to -3. And then multiply both sides by -5. It looks so messy. We're going to do this on the other board. All right, sorry about the mess. We're going to do this then. This stuff is +3, or what's in the bars will be equal to -3. Okay, back over here. Okay, so I subtracted 6 from both sides, then I multiplied both sides by -5, and when I do that, I get positive x equal to +15. x is left over on this side. Negative times negative equals a positive 15. And then we can do the other equation. So subtract 6 from both sides. Negative 5x. Negative x over 5 is equal to negative 9. Let me think about this. Something's going a little different than my notes. 4 I think I missed maybe a neg. I think when I started doing the scratch work, I might have missed a minus sign. But let's just let's check the time. We've got 5 minutes. So what we're going to do is say, I think that I wrote down a problem and now I've been solving something sort of different, but we're going to keep solving this. We're solving something that looks like this. So we have, I think I started with 4 equal to negative 1 plus the absolute value of stuff, and then I started working on 4 equal to positive 1. So let's stick with here because we're stuck on time. Solving this equation, first you isolate your absolute value bars, which we did correctly. And that makes that a 3. Then you set up 2 equations, which we also did correctly. Got stuff in the bars equal to positive 3, stuff in the bars equal to negative 3. Solve this one. Negative 3 times negative 5 looks good. All right, so let's solve this one and call it done. So if I multiply both sides by negative 5, that will get rid of that sign and that fraction. And do it on this side too. Okay. So this is a positive 5 over 5 is 1. Positive x is left on this side. And then a positive 45 on that side. Last one is a little messy and confusing, but I hope that the process makes sense. You start by isolating your absolute value bars. You then set up 2 equations, and you should get 2 solutions. So we're almost out of time. Are there any questions or concerns about your test? I'm going to make a quick comment. So I did not put absolute values with inequalities on your test, but they might show up on the final. So you do want to try those homework problems. And again, if you need more time on any of your homework assignments, just write an email to me. But I think that's good enough for the review. And just work on your test over the weekend and let me know if you have questions. Okay, thank you.